Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question which states that write the node voltage equations and find out the currents in each branch of the circuit shown in the figure below. So this is the circuit. We have to find the node voltage equations and find out the currents in each branch. So here are the branch currents. All the branch currents has been specified. So the first thing we are going to do is to identify all the principal nodes. In one of my previous videos, I discussed about all the steps you need when doing nodal analysis, all the steps you take. So the link of that video is down in the description below. You can check it out for better understanding of this exercise. So now in this circuit, there are three principal nodes. This one, and the bottom node, which is our reference node at 0 volts. Down here is 0 volts. This point down here, the whole, because at this point, all four branches intersect here. So it's also a principal node. From my previous video, the principal node is a point where more than two branches are interconnected. So this is a principal node, this is a principal node, this is also a principal node. So now you have to identify all the principal nodes. And to do that, you need the definition. You need to know what a principal node is. It's not like a simple node is a node where only two branches are interconnected. So now we have identified these principal nodes. So let's apply KCL to the first principal node. This is 1. So apply KCL here. KCL law. The algebraic sum of incoming currents that enter a node is equal to the algebraic sum of outgoing currents that leaves that node. So this node, the current that enters is 5. 5 is equal to I10 plus I3. So now let's apply Ohm's law. If you apply Ohm's law, 5 is equal to I10 is what? Is V1 minus 0. V1 minus 0 over 10, which is the resistance, plus I3. It moves from higher to this lower potential. So the higher potential is V1. V1 minus what? V2 over 3. So this is it. Then we'll simplify this equation. This becomes what? Let me put it here. V1 over 10 plus V1 over 3 minus V2 over 3 equals to 5. So we'll express this equation in terms of V1 and V2 separately. So we'll add this together. That's 1 over 10 plus 1 over 3. It's 13 over 30. So this will be 13 over 30 V1 minus 1 over 3 V2 equals to 5. So this will be our equation 1. Then we apply KCL to the second node, the second principal node. So it will be I3 equals to I5 plus I1. So I3 is equals to I5 plus I1. What's I3? I3 is V1 minus V2 over 3. V1 minus V2 over 3 equals to what's I5? I5 is V2 minus 0 over 5. V2 minus 0 over 5. Then I1 is what? I1 is V2. Now there's a voltage here. If there was no voltage here, it would have been minus 0, which is the reference node. But since there's a voltage here, it's now V2, and this is flowing from V2 to 10. That means this 10 is at a lower potential than V2. But when we solve it, we will actually know whether the current is actually flowing from V2 to 10. Because if this one gives us a lower value, maybe it gives us 9, that means we know that the current direction will actually be in the reverse. But it is only when you solve it that you actually know. So what you need to know is that this direction of flow is actually assumed. But when you solve it, that is when you know actually if your assumed direction of flow is the actual direction. So we'll see when we solve it. Then I1 now is what? Is V2 minus 10 over 1. So this is it. So we'll simplify this equation now. So now this becomes V1 over 3 minus V2 over 3 equals V2 over 5 plus V2 over 1, which is equal to V2 minus 10. So we'll correct like terms. Let's move all this thing here. This becomes V1 over 3 minus V2 over 3 minus V2 over 5 minus V2 equals to minus 10. So now we'll add this to be 1 minus what? Minus 1 over 3 minus 1 over 5 minus 1 over 5, then minus 1 equals to minus 23 over 15. So this becomes 1 over 3 V1 minus 23 over 15 V2 equals to minus 10. So this becomes our second equation. So now we have two simultaneous equations. You can solve them using any method you want, either elimination, substitution, Cramer's rule, but let's use Cramer's rule. And I'm going to also show you another simple way you can cross-check your answer using your calculator. So by Cramer's rule, AX equals to B. So A is the coefficient of V1 and V2. So in the first equation, the first coefficient is of V1 is 13 over 30 and 1 over 3. The second one. So 13 over 30, then 1 over 3. And the second one is negative 1 over 3. The second one is negative 23 over 15. Our variable is V1 and V2. Then B is this one, 5 and minus 10. So we will now proceed. So here is A, then we'll find the determinant of A. So the determinant of A is this, or we'll find using the calculator. But first let's write A1 and A2. So A1, you replace the first column with this. Replace the first column with this. So 5 and 10, 5 and negative 10. So it will be 5 and negative 10 here. Then is minus 1 over 3 and minus 23 over 15. So then the determinant of A1, we'll find it in the calculator. Then A2 we'll replace the second column by this. So it will be 13 over 30, 1 over 3, 5 minus 10. So this will be A2. So now we'll carry our calculator. Then we'll put these matrices in the calculator to find their determinants. In matrix mode, 5. So 13 over 30, then minus 1 over 3, and 1 over 3, minus 23 over 15. Then shift matrix 2, then B, and then 5 minus 1 over 3, minus 10, minus 23 over 15, shift 4, 2, 3, 5, 13 over 30, 5, 1 over 3, minus 10, minus 10. Then we'll save everything as an is. Then now we can find determinant. So 7, shift 4 at A. So the determinant of the first matrix is negative 0.553. Since it's decimal, let me take to 3 decimal place. Negative 0.553. You can also take to 4 decimal. So it's safer to take 3 to 4 decimal. Sometimes the worst you can do is to approximate to 1 decimal place. That won't give you the correct answer. So that won't give you the correct answer. 2 decimal place is sometimes manageable. But the best is between 3 and 4. Then mat B, minus 11. Then the third one, C, negative 6. So now, to find V1, V1 is now this over this. So it's negative 11 over minus 0.553. Negative 11 over negative 0.553. So it's 19.89 volts. Then V2, V2 is A2 with determinant of A2 over A. So it's now what? Negative 6 over minus 0.553. So negative 6 over negative 0.553. So it's 10.84, approximately 10.85. So it's 10.85 volts. So these are the two voltages. And the question states that write the node voltage equations and find, we have written the node voltage equations, those are the two simultaneous equations, and find out the current in each branch of the circuit shown in the figure below. That means we need to find the current in each branch. So in this branch now, we have already analyzed it here. So in this branch I10, the current I10 is already, the formula for finding the current is V1 over 10. So we'll just say I10 equals to V1 over 10. We know what V1 is. We'll say 19.9 over 10 is equal to 1.989 ampere. So now, then I3 is V1 minus V2 over 3. So we'll say I3 is V1 minus V2 over 3. That's 19.89 minus 10.85 over 3. 19.89 minus 10.85 over 3 is 3.01. 3.01 ampere. 1 ampere. The next branch, we have found the branch I10 and I3, the current. Then the next branch, we have found the branch currents I10 and I3. Now remaining I5 and I1. So I5 is what? I5 is V2 over 5. Then I1 is V2 minus 10. So V2 over 5. V2 over 5 is what? Is 10.85. 10.85 over 5. So 10.85 divided by 5 is what? 10.85 divided by 5 is 2.17. So that means to be 2.17 ampere. Then the last one, V2 minus 10, is 10.85 minus 10 which is 0.85. 0.85, which is 0.85 ampere. So this is it. This is I1. So this is I1, which is 10.85 minus 10. That's how we got this. 10.85 minus 10, which is 0.85 ampere. So I1 is equal to 0.85 ampere. So in case you're having an exam, maybe a CBT or an OBJ exam, and you don't really have time to use Cramer's rule, You can use your calculator this kind. You can use your calculator this kind. Just go to equations 5, then you select, if it's a 3 by 3 equation, you select this one. If it's a 2 by 2 equation, if there are 3 simultaneous equations, I need to find 3 variables, you use this second one. If there are 2 simultaneous equations and you need to find 2 variables, use the first one. So this one is our case. So we'll enter this coefficient. So this is it. These are the coefficients. The 2 equations. So you enter the first one is 13 over 30. Then negative 1 over 3. Then the last one is 5. Then the second one, 1 over 3. Then second one is minus 23 over 15. Then negative 10. So then you just weight it. See, this is our first answer. The one we got when solving it, you see 19.89. But this one is 8. If you approximate, it's still 88. So it's the same thing. Then V2 is what? 10.84. 10.85. So the same thing. So you can use this method sharply to get the answer quicker. But if you are doing AC, the best, you cannot do this method because you lose marks. You have to use this Cramer's or substitution rule or elimination, anyone. But don't use this kind to do an AC exam. This method is just to cross check your answer or for OBJ or CBT exams. So this is it. Now back to what we were saying at the beginning. We assume that current was flowing from V2 downward here. That means from a higher potential to lower potential. But now V2 is what? V2 is 10.85. 10.85 is actually bigger than 10. That means 2. This assumed direction is correct. The assumed direction here was actually correct because here will be 10.85 and here will be 10. So it will be current actually flows from a higher potential 10.85 to this lower one, which is 10, because 10 is lower than 10.85. 10.85 because 10 is lower than 10.85. And also current will flow from V1 here to V2. And here from V1, of course, downward to 0 volt. And of course from V2 downward to 0 volt. So all these directions that was assumed is actually correct. So that's it. That's the correct answers. These directions also is correct. The assumed direction is actually the same as the actual direction of the currents in the circuit. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified as soon as I drop a new video. Thanks.